today we are going to be looking at angles of elevation and depression. Please, if you are new to this channel, do ensure you subscribe and like our videos, as we'll be updating and dropping videos subsequently. Now, before we move ahead, let's talk about what an angle is. We all know that an angle is what? Is a meeting point between two or more lines, which is where two or more lines intersect. It forms what we call an angle, right? To illustrate what angles of elevation and depression mean, we have a diagram here of a man who is supposedly looking at an aeroplane above him. Now, the line of sight of the person and the aeroplane is looking at, there is an angle that is formed in between. We can call that angle the angle of elevation. So the angle between a person's line of sight and anything above him is the angle of elevation. Why? On this other diagram, we could imagine a person looking at maybe a stone or something on the ground. The angle that is formed between the person's line of sight and what he's looking at on the ground is called the angle of depression. Now we are going to solve some problems in this topic. But before we go ahead, we need to be familiar with trigonometrical ratios. We know what we call the SOHCAHTOA. I believe everybody should be familiar with the SOHCAHTOA. What does this mean? It means that the sine of an angle, the sine of the angle should be what? Opposite over hypotenuse. The cosine of an angle should be what? From this curve, this is A, which is the adjacent side, over the H, which is the hypotenuse. And tan theta should be what? The opposite side over the adjacent side. Because in a right angle triangle, when we draw a right angle triangle, and this is the angle, right? Angle theta. This side is called the opposite side, and the longest side of the right angle triangle is called the hypotenuse, while the adjacent side is this side. We have the first example. It says a woman is standing on the ground at a point 78 feet from the base of a building. The angle of elevation to the top of the building is 57 degrees. To the nearest foot, how high is the building? If you take notes, we were given two parameters. When you want to solve a problem, it is always good to note the parameters you are given. So they gave us the angle of what? Elevation. So giving angle of elevation to be what? They gave us 57 degrees. And what again did they give us? They gave us the distance from the woman to the what? To the base of the building. So let's call it D, to the what? 78 feet. Now it's always good when you want to solve problems like this, you need to sketch or a diagram that represents what the question is so that you'll be able to tackle it properly. So I'm going to make a diagram. They say a woman is standing on the ground at a point 78 feet. So let's assume that this is where the woman is standing at a point 78 feet from the base of the building. Right? Did they give us the height of the woman? No. So let's assume that this is the woman's line of sight. So, and let's assume that this is the building. So there is an angle of elevation that is here. And what is it? They gave us to be what? 57 degrees, right? Now they said the distance between the woman's line of sight and the foot of the building is what? 78 feet. So from here, we can solve. They say we should find the height of the building. This is the building. So let's call the height H. Let's make this a right angle triangle because that is it. Now, to solve this problem, we bring in the SOHCAHTOA. So from the SOHCAHTOA, let me write it up here. This side is the what? The opposite side. This is the adjacent side. So that means that we need to use the TOA, which contains the opposite and the adjacent side, since we are looking for the opposite side. So when we bring in the tangent of theta to be what? Opposite over adjacent, we know that tan theta is what? tan, the theta there is going to be the angle 57 degrees, is equal to the opposite, which is h, what we are looking for, over the adjacent side, which is 78 feet, right? Now, to find the height, we do what? We cross multiply. And when we cross multiply, we find out that h is going to be tan 57 degrees times what? 78 feet. Let me quickly do that on my calculator. So tan 57 gives me 1.539. Then when you multiply that with 78, you get 120.109 feet. And so what is the final answer? They say to the nearest foot, or to the nearest feet, the answer will be 120 feet. Now we have the second example we want to solve, the second question. And this time around is going to be on angles of depression. So it says an observer on a cliff 1000 dm cube above sea level sights two ships due east. The angles of depression of the ships are 47 degrees and 32 degrees. Find to the nearest decimeter, which is there, the distance between the two ships. Now, what were we given in this question? We're given the height of an observer. Now, let's sketch it. So, let's assume that this is a cliff, and they say the cliff is 1000 dm cube, 1000 decimeters high. Let's assume this is 1000 dm decimeters. And they say the man sights two ships that are due east. Now, from the cardinal point, this is east, right? This is north. This is south, rather. This is east. So, what happens? They say the angles of depression of the ships. So, the angle that is formed between the man's line of sight and the ships he can see from afar that are below him, they say it is 47 and 32 degrees. So, let's assume this is the man's what? Line of sight. The angle of depression, let's assume this is the 47 degrees part. It should be the 47 degrees. And again, they said this is ship A. Let's call the first ship A. And then 37 degrees should be somewhere here. Oh wait, let me make this diagram. Let me make the 47 go down a bit. So let's assume this is 47 degrees. And then again, from here, let's assume that this is 32 degrees. Don't mind my handwriting. This is the man's line of sight, and these are the two angles of depression. Now, this is the sea level. Let's call it the sea level. So, from this place, because these angles are alternate to this, right? We can bring 47 down here. This 47 is alternate to this angle, and we can bring 32 down here because they are alternate, right? So what are we asked in this question to do? The question says that we should find to the nearest decimeter the distance between the two ships. Let's call this ship A and let's call this ship B. We are asked to find the distance here between the two of them. Let's call it D. Now, how do we go about solving this problem? Well, I want us to, this is what we are going to do. We are going to assume that this is a right angle triangle as a whole, right? This is a right angle triangle. So we are going to find the distance from this place to this place. And then we also find distance from this cliff to ship A. We'll find distance from here to here and the distance from the cliff to ship A. Then we will take the difference and we are going to get the distance between the two ships. So for the first one, the triangle should look like this. Our right angle triangle, this is 47 degrees. This is 1000 dl. And this is the distance we are looking for, A. Then the second one, which is the second sheet, The angle there is 32 degrees. The distance is 1000. The height of the cliff is 1000 dm. And this is sheet B. So let's calculate. The first one, the trig ratio we are going to use will be this TOA again, like we used before, tangent, because we are given the opposite side and we are asked to find the adjacent side, and we have the angle. So we are going to have that tan theta is what? Opposite over adjacent. And we know that tan theta is what? Tan 47 degrees is equal to the opposite side is 1000 decimeters, and we are looking for this A. Let's just call it A for now. So to find A, we are going to what? Cross multiply. When you cross multiply, you have that we are going to have 1000 decimeters divided by tan 47 degrees. So let's quickly calculate that. Okay, so when you compute this, you should get something like 932.5 decimeters. And so I'm going to round this up so that my distance A, which is distance from the cliff to that ship, is going to be what? It is going to be 933 decimeters. Now we need to solve this for these two as well. And so to do that, we'll say what? The tan of the angle, which is tan 32 degrees, is equal to what? Opposite over adjacent again. So we are still using this tan, which is 1000 dm decimeters over B, because we want to get the distance from sheet B to the cliff. And so when you cross multiply, you get what? That B is equal to what? 1000 decimeters over tan 32. So let me quickly calculate that. 1000 decimeters over 32. You should get 1600.33 decimeters. So we've gotten B as well, have we? 1600.3 decimeters. To round it up, it's going to be what? 1600 decimeters. But this is now our final answer. We are asked to find the distance between the two sheets, and they say to the nearest decimeter. Okay, that we have already rounded it up, sir. So distance D, the small d, which is this that I drew in this diagram, is going to be B minus A. It's going to be, which is going to be 1600 dm decimeters minus, where is the other one? Okay, minus 933, to give us 667 decimeters. Now, the third example says a man 1.5 meters tall, standing 20 meters away from a tower, observes the angle of elevation to be 57 degrees. We have to calculate the height of the tower. So what and what did they give us? So from the equation, we are given the height of the man, which is 1.5 meters. They told us the distance from the man to the tower, which is 20 meters. And we have to calculate the height of the tower. Let's call this the height of the man, H subscript M, and the height of the tower to be H subscript T. They also gave us the angle of elevation to be what? 57 degrees. So let's make a small sketch. So let's assume that this is the height of the man, right? Let's write the 1.5 meters here. And now, the angle that is formed from the line of sight of the man to the top of a tower is what? The angle given, which is the angle of elevation, is 57 degrees. Now, we are also told that the man stands what? 20 meters from the foot of the tower. So this is our tower. Right? We are asked to find the height of the tower. Now, the distance from the man, the foot of the man to the foot of the tower is 20 meters, which means that the distance from the line of sight of the man to the tower is still 20 meters. So I can write 20 meters here because this is the triangle I am going to work with. So I have another right angle triangle, I have my angle, right? I can bring it out if I want to as well. So if I bring it out now, what do I have? I have 20 meters here. I have 57 and I have the height. But the height is not complete because the man's height is also involved. So at the end of the day, when we get this h, we are going to add it to the height of the man to get the total height of the tower. So let's find this. If you notice again, it is still what? Tan. It is still the tan of the angle we are going to use. So all the examples we've solved today involve tan. Or you could find out other examples that you make use of cosine or the sine of the angles. So let's go. So we have that the tan of the angle is what? Opposite over the adjacent side. Now, which is, if we now put in the angle, it is 57 degrees and it is equal to the opposite side, which is this h that we are looking for, over 20 meters. So when you cross multiply to find h will be 20 meters times tan 57. So I'll get 30.8 meters. Now we have gotten the height. But the total height of the tower is going to be this h plus the height of the man, which is 1.5 meters. So h total, or the height of the tower, is h plus the height of the man, which is what? Because this was the other part we neglected when we sketched out our right angle triangle, which is 30.8 meters plus what? 1.5 meters. So when you do that, 30.8 plus 1.5, we get 32.3 meters. So this is the height of the tower. So that is that for today's class. So if you have questions, please feel free to ask them and comment them down. See you in the next class.